All right, guys, welcome back. We're going to go ahead and continue on with example 5 of our lesson about double integrals. And so now we have our little notation here that we have the double integral of our xy plus e to the x, and the dA is actually represented by the delta x and delta y. And you also can see that the region that we're looking at here is, or x is between 0 and 1, and y is in between 0 and 2. So one of the things that I would suggest that you guys do is look at this and see what would be the easiest thing to integrate first, because you can put these in any order based on the video we just talked about. So if I'm looking at this problem, I'm saying, okay, I got x's in both these things and I only have one y right here. So my suggestion is to actually start integrating with y first. So with that being said, if I want to integrate with y first, I'm actually going to, on the x here, remember we work away from the inside out. So the first thing we're going to do here is we're going to do 0 to 1 for x, and then the integration from 0 to 2 of xy plus e to the x. And then we're going to do with respect to y first and then respect to x. Remember, it doesn't matter exactly which one you do first, but this is just a suggestion that I would have for us, because then we're only looking at the integration of the variable y. So e to the x is actually a constant here. So we're going to go ahead and do the integration from 0 to 1, and then we're going to integrate. Well, x is still a constant, so we'll just plop on x down, and we're going to integrate y as y squared all over 2. And then remember, the constant is e to the x, and we're going to go ahead and throw a y on that as well, right? Because we're just integrating a constant with respect to y. And then we're going to evaluate this whole thing from 0 to 2, and then we have our dx right here. So let's clean this up a little bit. It's getting a little messy, but we are okay with it. So we're going to integrate from 0 to 1. And so I have, again, I'm going to place the y. Everywhere I see a y, I'm going to replace a 2 for that, right? And technically plug in 0 at the end, but that's all going to go away. So I got myself a 2 squared. So actually, let's write this out here. So we got a 2 squared all over 2 plus an e to the x times 2 dx. Okay, so let me go ahead and just simplify that down or make it look a little bit prettier. So we have 0 to 1. So 4 over 2 is 2. So we have ourselves a 2x. Then we have a plus 2e to the x. Actually, let me make a mistake right here. This should be a change in x. All right, so there we go right there. And then all we have to do now is go back to, as I've been saying, basic calculus, and it's integrating this now with respect to one variable, right? And so the integration of 2x is x squared. The integration of e to the x is just e to the x. The 2 is still in front. And we're going to evaluate this from 0 to 1. So again, if I plug in, we get 1 squared, which is 1, plus 2e to the first minus 0 plus, and be very careful here, right? Not everything goes away with this problem, so we're going to plug in 0 here, and we get 0 plus 2e to the 0 power. So when all of this is said and done, we're going to be left with 1 plus 2e minus 2, right? Because e to the 1 is actually obviously 1. So we're going to get a final answer of -1 plus 2e, or 2e minus 1. All right. So pretty basic stuff, pretty easy. So now what I'm going to ask you guys to do for me is to pause the video and solve this problem for me. Thanks. All right, guys, so if you can look at this problem, I went ahead and solved it. I apologize if you try to do all this crazy math here at the bottom. We got a little insane here. But so first of all, we realize we have a rectangle, and so we're formed with x between 0 and 4, so and y is between 3 and 5. This is one of those problems because you could do x or y first, so I just went ahead and decided to do it with x this time. It doesn't really matter. The only reason that I chose x initially here is because one of my bounds is 0. So I know that when I do integrate this, that when I plug in 0, I will only have one term. So that is my big reason why I decided to choose x, because one of my bounds is 0 and I don't have to worry about something minus something else. So that's the whole idea here. But as you guys can see, it's pretty straight integration here. Just a friendly reminder again that when we're doing our integration with respect to x, that y squared is actually a constant. So that's why it is a y squared x. Evaluating 4, remember every time that we do that, just a friendly reminder that the 4 is only going to go into the x because we integrated with respect to x. Then we get down here to our blue step, and our blue step is exactly what you've been doing in calculus A, B, or BC. And then we just go ahead and integrate, plug in. I wish that these numbers would have been a little bit nicer for us, but yeah. So anyways, plug in 5 to both y's, plug in 3 to both y's, fundamental theorem of calculus part 1. And if we were to leave this, we're okay with that, but it does simplify down to 520 over 3. So I think that's a good stopping point for this video, and we'll come back in the next one. Take care.